In our last video, Alex successfully saved her first sentence. It's safe in the Git database as a blob, a perfect unchangeable copy. But there's a huge problem. Git has the content, but it has no idea what the file name was. How does Alex tell Git that this specific blob of content belongs to a file named chapter 1? Welcome back. Today we'll learn about Git's second major object, the tree, which acts as a table of contents giving names and structure to our raw data. Let's dive in. To solve the problem of the nameless blob, Git uses an object that works just like a folder. This is a tree object. Think of it as a single folder's inventory list. It's a simple text file that contains a list of all the items in a directory. For each item, it records the permissions, type, whether it's a blob or tree, basically whether it's a normal file or it's a subfolder, hash ID, and the file name. This is the crucial link that we were missing. The tree connects a human readable name like chapter 1 to the blob ID, the hash ID. So this is the link that Git uses to know that this hash ID, this blob that we saved here, is connected to this file name. Now, in the meanwhile, Alex has worked further on her book, and now she has another subfolder called chapters where she saved her work for chapter 2. Now let's take a look at how our tree, this root tree looks like now. So we see that we have the main tree with its hash ID. So just like blobs that have hash ID, tree objects also have their hash ID. And again, it is calculated based on all the files and subfolders inside that tree or basically that directory. So here we see that this tree previously only had this chapter 1 listed, which basically links chapter 1 to this hash ID of the blob. But now we have also chapters, file name as chapters, which has this hash ID. And the type is this time tree. So we see that the tree can contain blobs as well as other trees. Just like a folder can have files and subfolders, a tree similarly can have blobs as well as subtrees. And our chapters tree here with this hash ID, this itself will point to another blob. So we see that if we look at the chapters tree, and this is the chapters tree, it itself will list that chapter 2 is related to this hash ID. So to summarize, we were missing the link between the blob that was saved and the file name. And to find this, we will look into the trees. Git saves this information in objects that are called tree object. Basically, it's like a folder. Just like a folder can have files as well as subfolders, a tree object can also have basically blobs as well as other trees in its listings. It's like a table of contents or a mapping, a list of mappings between the hash IDs and the file names. Now let's see this in action. All right, I'm inside the directory Alex's book new. Let's see that we have our only file, chapter 1. Now before we continue, I want to emphasize that the commands that we saw in the last video, such as git cat file or git hash object, as well as the commands that we will see in this video, these are called git plumbing commands. And these are the commands that Git uses under the hood to do its magic. On a daily basis, we would not use these commands, but it's good to learn about them because this gives us a deeper understanding of what's going on under the hood. So if you don't understand exactly how these commands work, it's okay, but I would recommend learning these plumbing commands at least for once and trying them out. It's fun to do, and it also gives you a deeper understanding of how Git works. So we saw that we can use git hash object to save our chapter 1's content as a blob, and this is the hash ID. We see that if we do ls-a, we are in a Git repository. We have this .git folder that everything is inside, and this is of course our original chapter 1 file. Now I'm gonna look into Git objects directory, and here we see that this 1b is basically this blob, the current version of the content of chapter 1. We had also previously saved an older version, and we can use git cat file -p, and we can copy this blob ID and paste here, and we can see the content of chapter 1 here. I'm gonna also use cat chapter 1 just for you to see that it is exactly the same. So here I'm just using what we have in the directory, chapter 1, and here is what we have saved as a blob in objects directory. Now let's see how we can make the tree that will basically link this name chapter 1 to the blob ID. The first step is to add our file together, so our file chapter1.txt, together with its hash ID as well as its type to what is called an index or a staging area. Think of this as kind of a draft that will be saved later to a tree. All right, for that we need to use git update index --add --cache info, and then we need to give the type of the object, which is a file, and for a file we saw that we need to specify it with this specific number or ID. So this is basically a mode for a file or a blob. And then we will also copy the hash ID, which I'm gonna grab it from here. And finally, we will give the file name. And we will hit enter. We're basically adding this file name, chapter 1, and linking it together with this hash ID and the mode or the type, which is a file. And we're adding it to our index. And we're using this --cache info because we have already saved this as a blob. We have already saved this using git hash object. So we have already saved it in our objects directory here. Because it's already cached or saved in this objects directory, we also provide this that, hey, use this blob, use this from the content is inside this objects directory. It's this one, this blob. The second step is now to save this permanently as a tree object. And to do this, we will use git write -tree command and hit enter, and we see what is returned here is the hash ID of the tree object. First, I'm gonna take a look at the objects directory, and we see that now this folder here 51 is basically the two first characters. So this is our new hash ID of this tree, and we can look at it with, again, using git cat file command, and I'm gonna copy the whole hash of the tree, and we see that it is indeed a listing. So it only has one entry, one row, which shows the mode, this is for a normal file or a blob, and this is the hash ID of the blob, and this is the file name. So it links this file name chapter 1 to this hash ID or blob ID, which is this one that we have saved in the objects, the current version. Now I'm gonna also use git cat file with -t, and again the hash ID of the tree, just to confirm that it is a tree. And this with -t, it gives us the type of the object, which is a tree. So we use two commands to basically get to our tree. First, we used update index command, which basically adds this file chapter 1 to an index or staging area. And then we saved that staging area or the index to the tree with this git write tree. And we see that when we made the tree, we get a hash ID for the tree. We see that Git adds it to the objects directory, and we used cat file with -p to look at the content of this object. And we see that indeed it's basically a listing which only has one mapping, which maps chapter 1 name, file name to this blob ID. All right, let's make a directory called chapters. So now we have also this chapters directory, and I'm gonna go to that directory, wait, chapters, and we see that there's nothing in the directory. I'm gonna clear the terminal, so there's nothing here. Now let's create chapter 2 file using echo command. Let's say we have this sentence, the plot thickens, and we save it in chapter 2.txt, and we can see that now we have this file inside chapters 2. I'm gonna go one directory up to our main parent directory. So we had this chapter 1. Now we created another subfolder inside our book new, and then inside this chapters we have chapter 2 file. Now let's use git hash object as before, and to write or to save the content of chapter, which is inside chapters, chapter 2 as a blob. And here we go, we have the blob for our new file, which we can, I'm gonna copy. We can use git cat file again with -p to see what is inside, and we see that it comes from chapter 2 file. Now let's add both of the files to our index and then write it to a tree, and then take a look at how it looks. So we will use git update index --add --cache info, and then we will, because they are both normal files, this is the mode of the file, and then we need to get the hash ID, which I'm gonna copy from here, paste, and then the file name, which is chapters chapter 2, and here we go. Okay, let's take a look at the .git objects directory. We see that we had these two as the first version of chapter 1, the second version of chapter 1, and then we had the tree object, and then we have the new file chapter 2. So I need to get the hash ID of first file, which is this one. So I can just do git hash object again, chapter 1, and this is already exists, so which is this one. So I just want to copy this so that I can add it to the index. So let me find the long command, and here I can paste the hash ID for chapter 1 as well as the name, which is chapter 1. Here we go. Now we have added both of our files to the index, and now we can use git write tree again, write tree, and here we are. Now we have a new tree object. We look at the .git directory, and we see this object here, subfolder 70, which comes from here. So we have a new tree, and let's take a look at our new tree with, again, cat file dash. First of all, we can use -t to see the type, which is a tree. And now I'm gonna do -p to see the content. Let's see what is in our tree. And we see that we have this time 2 rows. So the first row is as before, a normal file, which is a blob, hash ID or the blob ID, as well as the chapter 1 file name. But now we also see this a different mode, which is for a tree or a folder. Basically the object is tree, and this is the hash ID of the tree, and this is the name of the folder, basically chapters. We can further see what is inside this tree. So I'm gonna copy this and I'm gonna use git cat file -p again. So I'm gonna see what is inside this tree chapters. And inside we see that it only has one row or one mapping, which basically maps chapter 2 to its blob ID. All right, so we just used two commands, update index, to first update the index or staging area with our files, and then we can save that staging area to a tree with using git write tree command. With these two commands, we can basically create our tree object, such as this one that is created, and we can use git file -t to check the type or git file -p to look at the content. Basically, it is a table of contents that maps a file name to blob ID. Now we have solved a big part of the puzzle, which was how Git basically maps file name to the file content. But something is still missing. Who made this change? When did they make it? And why did they make it? So we have a snapshot, the tree object that contains the table of contents, but we have no context or no history. To solve that, we need the third and final fundamental object in Git, the commit. And that's exactly what we'll build in our next video. See you then.